Effective network troubleshooting begins with the OSI model. By isolating issues to specific layers, from physical cabling at layer 1 to application protocols at layer 7, you eliminate guesswork and focus your diagnostic efforts precisely where the failure occurs. The IP command is your primary interface for modern network administration. It replaces legacy tools, providing instant access to interface states, IP addressing, and complex routing tables with a single powerful syntax. Ping utilizes ICMP echo requests to verify reachability and measure round-trip latency. It provides an immediate heartbeat check, confirming whether a remote host is active and how long it takes for a packet to complete its journey.
When connectivity fails mid-path, traceroute maps the entire route to your destination. It identifies every hop, allowing you to pinpoint exactly where a packet is being dropped or suffering from excessive delay.
Always follow a systematic approach. Verify your local interface first, confirm connectivity to your default gateway, and only then test remote paths. This logical progression ensures you resolve local misconfigurations before investigating external network issues. We begin by clearing the terminal to provide a clean workspace. This ensures our focus remains entirely on the network diagnostic commands we are about to execute, keeping the output organized and easy to read as we investigate our system's connectivity and interface configuration. First, we update our package list and install essential networking utilities. By pulling in iproute2, iputls ping, and traceroute, we equip our system with the standard toolkit required for modern Linux network administration and troubleshooting. These packages provide the foundational binaries needed to inspect interfaces, manage routing tables, and verify end-to-end connectivity across the network. Executing IP-link show displays the status of our network interfaces. You can see the loopback interface and our primary Ethernet connection. This command is vital for verifying that your hardware is detected and that the physical or virtual links are in an up state, which is the necessary first step for any network communication. Next, we use addr show to inspect the specific IP addresses assigned to our interfaces. Unlike the link command, this reveals the layer 3 configuration, including IPv4 and IPv6 addresses. Understanding these assignments is crucial for identifying how your machine is addressed on the local network and whether it has successfully received an IP configuration. The IP route command reveals our system's routing table. This table dictates where packets are sent when they are destined for networks outside our local segment. By identifying the default gateway, we can determine how our traffic exits the local environment to reach the broader internet, which is essential for diagnosing connectivity issues. We now ping the loopback address, 127.00.1. This is a fundamental test to verify that the local TCP/IP stack is functioning correctly. If you can reach the loopback, it confirms that your network software is running properly on the host, regardless of the status of your physical network hardware or external connections. Now we test external connectivity by pinging Google. This confirms that our system can resolve domain names and reach remote servers across the internet. The round-trip time metrics provided here give us a quick snapshot of our network latency, helping us verify that our routing and DNS configurations are working as expected.
Finally, we use traceroute to map the path our packets take to reach Google. By limiting the hops to 10, we can observe each gateway the traffic passes through. This is an invaluable tool for pinpointing exactly where a connection might be failing or experiencing high latency along the route to a destination.